So, today we are going to discuss about velocity ratio of epicyclic gear train. We can solve this velocity ratio of epicyclic gear train by two methods. One is tabular method, another one is algebraic method. So, the tabular method is very easy to calculate the velocity ratio of epicyclic gear train. So, this tabular method is very easy to solve the velocity ratio of epicyclic gear train, and already we discussed in our last video. This is the layout of epicyclic gear train, and A is a sun gear and C is arm and B is a planet gear, right. A it rotates about O1 axis and the B it rotates with respect to the O2 axis. Already we discussed in our previous video. Just take a look. And so, for a tabular method, first we have to draw the tabulation. So, leave it this case, that we will discuss later, right. So, these are the constraints or conditions of the motions. So, this is a fixed one. So, we have to write these 4 steps, right. So, first one is the arm is fixed and gear A rotates plus 1 revolution. So, plus revolution belongs to anti-clockwise direction. If the gear A rotates in anti-clockwise direction, then we have to consider plus sign, whereas the gear A it rotates in the clockwise direction, then we have to consider the sign which is negative, right. So, anti-clockwise which means positive and clockwise which means negative, right. First we have to write these 4 conditions, right. So, arm is fixed and gear A rotates through plus 1 revolution. So, we have to assume the speed of gear A which is plus 1 initially, then the second condition, instead of plus 1 revolution, so we have to assume plus x revolution, right. So, arm is fixed and gear A rotates through plus x revolution. We have to assume x. Then in order to form the equation, we have to add plus y revolution to all the elements, right. Then the final one is total. We have to add these 2 steps, step 2 and step 3. We have to add these 2. So, for that here 0. For example, 3 gears are there, 2 gears are there. This is arm C, gear A and gear B, right. So, now arm C is fixed here and gear A rotates plus 1 revolution, right. So, arm is fixed, so that is why here 0. The speed of NC, the speed of the arm C which is 0, right, because here arm C is fixed. So, our condition is arm C is fixed, that is why the speed of C which is 0 and the gear A rotates plus 1 revolution. So, which means the NA, the speed of NA which is equal to plus 1, why plus. So, here we are assuming anti-clockwise direction. So, anti-clockwise which means the sign which is plus, right. Then how to calculate the gear B, right. Already in the layout, see the gear A is meshed with gear B externally, right, externally. So, the gear A it rotates in the anti-clockwise direction. Then what about gear B? Gear B it rotates in the opposite direction, right. Gear A it rotates in anti-clockwise direction, then gear B it rotates clockwise direction, right, because gear A and gear B both are meshed externally, right. So, here the gear A it rotates the plus 1 revolution. Then what about gear B? How to derive this equation? The speed of NB divided by speed of NA. The speed of gear B divided by speed of gear A which is equal to the teeth of A divided by teeth of B, right. So, NB which is equal to TA divided by TB into NA. So, what is NA? NA which is equal to plus 1. So, into plus 1 which means TA divided by TB, right. So, which is equal to the speed of NB, right. So, then how minus sign is there? Here the gear A it rotates anti-clockwise direction, that is why plus. Here the gear B it rotates clockwise direction because gear A and gear B meshed externally, right. So, we have to add minus sign, minus TA divided by TB, clear. The next condition, arm is fixed and gear A rotates plus x revolution. So, instead of plus 1 we have to substitute x value plus x, right, and he into into minus x into ta by tb. Instead of plus x, instead of plus 1, here x is there, right? Then add y revolution, plus y revolution to all the elements. So we have to add plus y and plus y. Then finally the total, which is equal to addition of second step and third step. So 0 plus y, which is equal to y, and plus x plus y. So x plus y. Here minus x into ta by tb plus y. So plus y minus x into ta by tb. This is how we have to solve this tabulation method, right? So let us discuss a simple problem now. So I'll read the problem. In a epicyclic gear train, the members are fixed sun gear S with 50 teeth, right? So teeth of S, which is equal to 50. Clear? This is given data. So whatever may be the problem, first we have to write the given data, right? Then second one, the planet gear P with 20 teeth. So TP, which is equal to 20 teeth, and the arm, the name of the arm, which is A arm, which is equal to A, right? So name of the arm, which is equal to A. So here this is arm A and this is sun gear, we know that, and this is the planet gear P, right? So sun gear S and planet gear B both are meshed externally, right? If sun gear, it rotates in anti-clockwise direction, then the condition, it should be opposite. I mean the rotation of planet gear, which is in the opposite direction, right? So this is the concept. Then the arm rotates about the sun gear axis at 50 rpm in the clockwise direction. So arm, it rotates about the sun gear axis O1, which is equal to 50 rpm. Though, so the speed of NA, I mean the speed of the arm, which is equal to 50 rpm clockwise. This is very important. The sign is very important, right? Then determine the speed of planet gear. So NP we have to find and direction we have to find. Clear? So before solving this problem, first we have to draw the tabulation, right? So this is the tabulation, and this is first condition, second condition, third condition, and this one is total fourth, right? So first we have to write, so arm A is fixed and the gear sun gear S, it rotates plus 1 revolution. We have to assume the sun gear S, it rotates plus 1 revolution counterclockwise direction, which means anti-clockwise direction, right? So arm is fixed, that's why this is the speed of NA and this is the speed of NS and this is the speed of NP, right? So arm is fixed, so which means there is no rotation, right? So the speed of NA, which is equal to 0. Next, the gear S, it rotates plus 1 revolution. So we are assuming plus 1 rotation for gear S, anti-clockwise direction, that's why plus 1. And what about gear P? So gear S and gear P both are meshed externally, so we have to find the equation. So speed of NP divided by speed of NS, which is equal to TS divided by TP, right? So NP, which is equal to TS divided by TP into NS, right? So NP, which is equal to, what is the value of TS? TS already we know that 50, right? Divide by, what is the value of TP? 20, right? So here 20 into plus 1, and what is the value? What is the value? Directly we will substitute the same, right? So 50 divided by 20, which is the speed of NP, but the sign which is in the opposite, I mean negative, because the speed, I mean the direction of NS, I mean the direction of gear S in the anti-clockwise direction. Then what about gear P? Gear P rotates automatically clockwise direction, so that's why here negative sign, right? So next, the second condition, arm A is fixed and gear A rotates minus x, I mean plus x revolution, right? Plus x revolution. So here the arm is fixed, that's why 0, and instead of plus 1, plus x, and here minus into x 50 divided by 20. This is the equation, right? Minus x into 50, right? Why minus? Because the gear P, it rotates clockwise direction, that's why. Add y revolution. So plus y and plus y. So what is total? So here plus y and here x plus y, and this is y minus x into 50 divided by 20, right? So this is the speed of NA, right? And this is speed of NS, and this is speed of NP. So this is the equation of speed of A and speed of NS and speed of NP. Clear? So now we know that in the given data, see here the speed of NA, I mean the speed of arm, which is 50 RPM clockwise. Then what is the equation here? So NA, which is equal to plus y, so y plus y, which is equal to speed of NA. Speed of NA how much? Speed of NA 50 clockwise. So 50, so this, the direction is clockwise, that's why here minus. So y, which is equal to 50 RPM. So this is we got from the given data, and now we have to find the speed of NP, right? We have to find the speed of NP. So then what is the use of this? So before that, see the equation of NP, y minus x into 50 divided by 20, the 50, 20 known value and y is also known value, x we don't know. So first we have to find the x, then only we can able to solve this NP, right? So for that we have to take this equation ns, which is equal to x plus y, right? So now we know that y, which is equal to minus 50 RPM, right? And now the second equation x plus y, which is equal to the speed of ns, right? Now the ns we don't know, right? The arm rotates about the sun axis at 50 RPM in the clockwise direction. Determine the speed of the planet gear and its direction of rotation. Here the members are fixed. Sun gear is fixed here. So ns, which is equal to 0. So put ns, which is equal to 0, because sun gear is fixed. Sun gear is fixed, right? So x we don't know, plus y, what is the value of y? Minus 50, which is equal to 0. So x, which is equal to 50 RPM, right? So this is the value of x. Now what is the equation of NP? NP, which is equal to the planet gear, speed of planet gear, y minus x into ts divided by tp, so which means 50 divided by 20, right? So here, so speed of NP, which is equal to, what is the value of y? Minus 50, then minus 50 into 50 divided by 20, right? So this is the value after substituting the value in this equation, right? Now so minus 50 of 50 divided by 20, so what is the value here? So 50 divided by 20, which is 2.5, right? So 2.5, so 2.5 into 50, which is equal to 125, right? So minus 50 minus 125, which is equal to minus 175, is the speed of NP. So minus sign, which indicates it is a clockwise direction, right? So NP, which is equal to 175 clockwise, right? So direction of NP, which is clockwise direction. We know that here this is the sun gear S and this is the planet gear P, right? So we assumed the sun gear, it rotates in the anti-clockwise direction. Then what about the direction of P? So see, sun gear S and planet gear B both are measured externally. So automatically, if the sun gear it rotates in anti-clockwise direction, then the planet gear B it rotates in the clockwise direction. See the result, it implies the speed of NP 175 clockwise direction. Clear? See y, which is equal to minus 50, right? So we got, then x, which is equal to 50 we got, then the speed of gear B, which is NP, which is equal to minus 75, then which is 175 clockwise direction. So this is how we have to solve the problem. Okay. So now one more another problem. It's a simple problem. In an epicyclic gear train, an arm carries two gears, gear A and gear B, having 36 and 45 teeth respectively. So gear A, the number of teeth which is equal to 36, and the gear B which is 45, right. So TA which is equal to 36 and TB which is equal to 45, right. If the arm rotates, so arm NC which is equal to 150 RPM anti-clockwise direction, right, about the center of the gear A, which is fixed, right. Here two conditions are there, right. See, they were asked two questions differently. First question is find the speed of gear B when A is fixed, right. Then second one is find the speed of gear B when A makes 300 RPM clockwise, right. So they were asked two questions: find out the speed of gear B when the A is fixed, and find out the speed of gear B when A makes 300 RPM clockwise, right. The problem is very simple, already we discussed in the previous videos. Similarly, we have to draw the tabulation, right. So already we know that how to draw the tabulations, everything. First we have to write the given data, TA which is equal to 36 and TB which is equal to 45. Then the speed of arm C which is equal to 150 RPM anti-clockwise direction, right. So remember, this is anti-clockwise, clear. Now draw the tabulation and write the conditions of motions, right, and we know that how to fill this. So arm C is fixed, that's why here 0, and we have to assume the gear A rotates plus 1, I mean anti-clockwise direction. So plus 1, then we have to find the ratio. Using this ratio method, we have to find the gear B, right. So NB divided by NA which is equal to TA divided by TB, right. So NB which is equal to NA into TA by TB, NA which is equal to plus 1, right. Here what is how minus, because so gear A rotates anti-clockwise direction, then gear B rotates in clockwise direction, that's why here minus sign, right. And we have to assume instead of plus 1 plus x and 0 plus x, and substitute these values and add plus y revolution to form the equations. So plus y plus y and add these two steps 2 and 3. So 0 plus y, x plus y, and plus y minus x into TA by TB, as we discussed in the previous video, right. Then now we have to substitute the values, right. So what is the equation? Y, x plus y. So here NC which is equal to plus y, right, speed of C. Then here NA which is equal to x plus y, right. Then NB which is equal to plus y minus x into TA by TB, right. See, y minus x into TA by TB, right. This is the equation, right. So this is equation 1, equation 2 and equation 3. The first question, find the speed of B when A is fixed, right. So now here NC which is equal to 150 RPM anti-clockwise direction, which means positive value, right. So here, so NC which is equal to plus y, so NC which is equal to 150 RPM. Now we know that, right. So NA is fixed, right. So NA is fixed, which means there is no revolution for speed A, gear A. So substitute 0 for NA, right. So 0 which is equal to x plus 150 RPM. So x which is equal to minus of 150 RPM. This is the value of x, right. Now we have to find the speed of NB, right. So NB which is equal to, what is the value of y? Y which is equal to y, right. So y which is equal to 150 minus and x, what is the value? Minus. So, minus of 150 into what is the value of TA? TA which is equal to 3645, right. So, here 36 divided by 45, right. So, here plus minus into minus plus. So, 150 plus 150 of 36 by 45, right. So, what is the value? 36 divided by 45. So, here 36 divided by 45 which is equal to 0.8. So, NB which is equal to 150 plus 150 of 0.8, right. Here 150 plus 150 into 0.8 which is equal to 120. So, 120. So, NB which is equal to 270 RPM. This is plus sign, which means anti-clockwise direction, right. Clear? Now, find out the speed of NB when NA makes how much? NA makes 300 RPM, 300 RPM clockwise, clockwise which means minus, right. So, 300 RPM clockwise, 300 RPM clockwise, clear. So, now substitute NA which is equal to 300 in this equation, right. So, now we know that the equation NB which is equal to 150 minus, take this equation NA which is equal to x plus y, right. So, instead of substituting 0 value this previous case, now we have to substitute 300 minus of 300 which is equal to x plus y which is equal to 150. So, x which is equal to how much? Minus 300 minus 150 which is equal to minus 450 RPM. This is the value of x. Now, substitute in this equation. So, NB which is equal to 150 minus of 450 into 36 by 45, right. So, here what is the value? 36 divided by 45, 0.8 into 450 which is equal to 300. So, 150 plus 360. So, NB which is equal to how much? Plus 150, 510 anti-clockwise direction, right. Final answer for first case NB which is equal to 270 RPM anti-clockwise. Second division NB which is equal to 510 RPM anti-clockwise when NA rotates 300 RPM clockwise, right. Thank you.